Welcome to the bug collecting track. You are here to hear Raj and Jeremy talk about network streaming and debugging with Mallory. So let's give them a hand.
All right, well, good afternoon, everyone. I hope everyone had a good lunch, and I'd like to thank you guys for attending our network debugging with Mallory. So we're just going to do some quick introductions so we can kind of get to you guys to get to know us a little bit. After that, we're going to talk a little bit about what we do over at Intrepidus Group and how specifically those interactions led to help us figure out, hey, we need to develop this new tool called Mallory. So we're going to explain why we believe Mallory needs to exist, and then after we do that, we're going to show you how we put it together, talk about a little bit the architecture of Mallory, how it works, and how you guys can help code and develop on it and try to make it a little better. And then after that, we'll get into some demos to show off a little bit about how Mallory really can help pen testers doing these one-off TCP-based or UDP-based network application assessments. So who exactly are we?
I'm Jeremy Allen. I'm a principal consultant at Intrepidus Group. I've been doing information security consulting for about 4.5 years now, and prior to that, I developed software for a bit over 10 years, so I've been in the information technology industry for a while. I teach secure coding, I write a lot of Python code, and I try to break stuff and hopefully share with others about how I broke things. So that's what I do.
My name is Raj. I guess you can call me the youngin of the group. I graduated about 1.5 years ago, and I was pretty fortunate to get picked up by the Intrepidus Group and have a lot of the guys help me out and mentor me and get into security a little bit more. I deal with a lot of mobile application security right now, specifically dealing with mobile apps on iPhones, Androids, and such. And I feel pretty lucky that I get to deal with that kind of stuff because according to my colleagues, a lot of the bugs that I'm finding are these legacy bugs that used to be in like web applications 5-10 years ago, but they're popping up again. So I feel a little lucky about that. I get to learn from the bottom up still. This is my first Blackhat, so I'm definitely pretty excited to be presenting to you guys right now. So what exactly do we do? Before we get into that, we just want to whet the appetite a little bit and just show with a quintessential proxying example that people have seen all the time done in very different ways, what Mallory can do and how it can do it very easily. I'm going to bring it up really quick, and Jeremy's just going to explain what I'm doing.
All right, so this is just a pretty simple example of flipping images around and inverting images in on a kind of local test network we have. This is all running internal. We didn't want to try and do internet for live demo because we feared it would explode. But basically, we have a WordPress site installed, and when you look at images, they'll be flipped upside down, and the colors will be reversed. And you've probably seen that done a number of different places in a number of different ways. But the point was that this took us about 15 to 20 lines of code, and it's pretty simple and straightforward. So that's kind of was our goal, is to make man-in-the-middle tasks easy for our application testing. So I know it's not that exciting, but we did a lot of that kind of stuff inside of Mallory that is a lot more exciting.
Yeah, and the cool thing to note is that it is being done within the stream. It's not like it's taking the picture, putting it somewhere, changing the picture, changing the HTML to point to new pictures, actually doing that manipulation within the TCP stream itself. So so a little bit of introduction on why we, what do we do and how does that lead to us wanting Mallory? Well, we do a lot of mobile application assessments. A lot of these assessments, they happen on brew devices all the way up to Android devices, from the very simple to the very complex mobile application operating systems. These applications, they obviously have network streams that we're used to, HTTP and whatnot, but sometimes they don't, and we'll get into that a little later. A lot of times we are dealing with embedded devices or applications on the embedded devices themselves. Again, these applications on these embedded devices, they're not often given us from a white hat point of view. We need to do a black box assessment. We won't have access to the code. We're not going to have access to the development environment. So we need to figure out a way to how are we going to assess this application if we can't, get that code and put it back into our computer and use our regular tools. We're going to need to get at the stream itself and start our assessment process dynamically within that stream. So that kind of helps set the tone that if you're doing this application assessment on, let's say, this web application on an embedded device, you need to be familiar with the network side of the house as well, and you need to figure out how am I going to get at that stream and do my manipulations. We do all the web application stuff, obviously. One of our friends like to say cross-site scripting pays his bills, so I kind of like that little anecdote. And we do a lot of this black box stuff, so if you have a Java thick client or a natively coded thick client, a lot of these times these things don't use HTTP. They'll use some proprietary protocol the developers thought that they needed to make. And how do we assess these things if we can't use a burp or a paros or a PFI to get at that stream? So just to get a little bit more specific, during these assessments, like I've been alluding to, it's often the case that a developer will try to use something that's well known, HTTP. It's easy, people know about it, it's easily understandable, and it's easy to develop on. But the problem is they don't always need to use that. They can do their own thing. Also, there are a lot of competing algorithms out there, such as the remote procedure call for flash, like AMF, where it's not HTTP, it's something else. Proxies are trying to catch up to deal with that kind of information, but it's still not exactly there yet. And even if they do use HTTP, they might not be using it in a fashion that the RFC explicitly was written for. They might be doing something very interesting, and we have a pretty interesting example about that, which kind of highlights, oh, hey, we might need another tool that's not already out there.
So one of the things that we encountered was application. We first saw it sending traffic, and it looked, oh, it's HTTP, but it was a whole system for displaying, streaming video and things like that. And essentially, after the first request, all it was a bunch of a long-lived socket that just sent binary video data across the wire. And when you try and test that in something like Paros or Burp, and you have a lot of data flowing, and you have data that's not really interpretable as HTTP, it tends to break your proxies and not work, because it's not really HTTP. It's just something developers stuffed on top of HTTP, and that's a pretty common thing when mobile platforms provide HTTP libraries or what have you, but you don't really want to use HTTP as a developer. So we see that a lot.
So again, just to get really specific here, often isn't always. Developers don't need to use HTTP. They can do their own binary protocols. That gives us a hard time when we need to assess things. And there are Flash applications, ActiveX applications, where even if you're on a web app, again, you're not limited to only using HTTP, which means the security tester needs to not think that all I need to know how to use is an HTTP proxy. So let's go a little bit more specific on what are the annoying characteristics to an assessment that's kind of being done on an application that way. Well, if you're not using HTTP and if you're not using a well-known protocol, that means there's probably a tool out there that you can't use, or there's not a tool out there that you could use. That's the contrapositive thing. Anyways, so what that means is, okay, we need to roll our own client. We're going to need to write some special code. We're going to need to set up some special environment to get this information from the application under test or the device under test into our control and then back out to the server. That often means that we're writing very specific snippets of code with some general behavior, but there's specific information within the general behavior that's tailored for the application at hand right now. Then when the application assessment is over, we have to throw that code away. Then the next application comes and we have to do it all over again. And we're programmers at heart. We're lazy. We don't like to do that. Who likes to throw their code away that they work so hard on, right? So that's one of the main big annoyances of dealing with these kind of applications, that you need to do these one-off codes, one-off code examples. Also, another annoyance is if there is a proxy that kind of deals with what we need to do, often it doesn't do enough, or it does too much for us, and we need to kind of personalize it a little bit. But these proxies might be closed source, or they might be written in such a way that it's not friendly for a person to get in there and start putting in a plugin or messing with the behavior ever so slightly just to get our functionality that we want out of it. Another interesting example is, again, if it's not using HTTP, what is it? Like I've been saying from the beginning of the presentation, but it's the biggest motivator for us. If they're not using HTTP, if they're not using TCP, say they're using UDP over some random port, how are you going to be able to pause that traffic, edit it, and send it on? There's not very many tools out there that can accomplish this. We needed that kind of functionality. Also, say they are using some kind of well-known protocol such as SSL. We all know about SSL. We all know we can man-in-the-middle SSL. But what happens if they put a proprietary protocol within the SSL stream? Now all of a sudden you have some tool, man-in-the-middle SSL, gets the plain text, and has no idea what to do with it. Now you can't edit the tool and you can't do anything with that. And we recently came across an example with that, which highlights our first real-world use of Mallory. Jeremy can get into that a little bit more.
Right. So one of the things that we encountered was an application that was stuffing a bunch of TCP streams inside of an SSL stream. So, kind of like a VPN, but not exactly. Some remote display technology, essentially. And with Mallory, one of the first things we did was, tell it to man in the middle of this port as SSL traffic. It unwraps it, it sends it to our GUI, and we were able to, edit hex bytes and send it on its way and encounter interesting behavior in the application. And that's one of the itches we really wanted to scratch. We're going to talk about is generically solving this whole problem of sometimes you just want a simple TCP proxy, not a full-blown HTTP proxy or whatever. So that's a really good example of places where Mallory really helps us.
And Jeremy's been using Mallory for a long time, so I feel he kind of is spoiled and doesn't understand exactly how awesome one line that he just said. He was like, we told Mallory on a specific port, this is SSL. Now do all the magic that we've coded you to do with SSL already. That's it. It was like on a random port with all the functionality we've already implemented for SSL, hey Mallory, that's SSL. Just do what you need to do, which is really awesome when you see how quick we can use that to start our assessment processes. But we'll get into that a little later. So why is this difficult? You don't have to believe me that it's difficult. I will explain to you why we believe it's difficult, because these are the processes that we have to go through every once in a while when we get these hard applications to assess. So the first thing we normally need to do on some application that we don't know the protocol and we don't know the ports and we don't know any of the other information is sniff it. We all know Wireshark. It's an invaluable tool to all of us as we do our assessments. We can pull the source port, we can pull the destination port, we can pull the IPs, the servers, any kind of buffer sizes that might need to be honored by mobile applications especially. Write that all down, save it, so that we can now start setting up our environment to perform our assessment. So after we get this information, we need to figure out a way, how do we break into that stream of data? So there's a number of ways that we all know that we can get into that stream of data. Some of them are more, I guess, developed for malicious purposes, and others might not be, but let's go over some pros and cons for these. So there's ARP spoofing. Essentially with ARP spoofing, you need to make sure that the client and the application supports gratuitous ARP. You need to make sure that the cache holds the information long enough such that it will send all the information to this man-in-the-middle gateway that we've ARP spoofed. Sometimes, though, these devices don't support gratuitous ARP. Sometimes the cache refreshes too quickly. We'll miss a packet or two, and then what happens is we don't get the full stream. And having a non-deterministic testing environment during an assessment can be vexing, to say the least. You will see things that you should see. You might not see things that you're expecting. That doesn't help you out when you're trying to assess an application. So ARP spoofing wasn't the way to go for us. There's DNS spoofing as well. Now what happens with DNS spoofing is we've come across a number of applications that, one, hard-coded IP addressing, or two, it's on an embedded device that we can't change the configured DNS server on. It's a closed device. You can't root it right away. We have a week for the assessment. We can't spend time to get at the bus and rewrite firmware to get at that. So we couldn't rely on DNS spoofing for our task. It was too specific, and it wasn't general enough for us to use it on every single assessment all the time. Well, there's a little bit more general way. After we do the research and we do the reconnaissance and we get all the destination networking information down, we can be IP tables ninjas, run information through our gateway that we control, and start redirecting traffic to the local host, our gateway, and hopefully to some interesting code that you're going to be running. Now the problem with this is I don't deal with IP tables every day. I don't want to memorize all this stuff, although it's not too difficult, but I don't need to. You don't need to. We're lazy again. We don't need to do these things if we don't have to. We want to be more efficient. So we kind of didn't want to deal with these one-off IP table rules per application based on varying ports and varying destinations. Like, we wanted this to be done automatically for us. But let's say somehow we were able to get into the stream of data. Now we're able to focus that stream of data into something that we control. What's the next step? Well, the next step is to spin up some listeners, spin up some forwarders, and make sure you have the communication. And when you have that communication, where you see that little pipe there, we would put code that we wrote, those one-off scripts that we were talking about, those one-off scripts that we throw away after every assessment because we don't need it anymore. We need to do something else. But again, if this is the way we have to do it, this is the way you have to do it, which gets annoying. And Jeremy will talk a little bit about, some of those scripts that we might use.
So essentially, in between the listening pipe that's reading the data in and the pipe that sends the data out, you add another pipe, which is for your script that you'll write, essentially something like netset, or maybe your sorry, lose my train of thought there. Anything that you would need to modify to, capture the state of the application, replace data that's going across the stream, things like that. So basically, you end up writing a custom Python script that reads the data, does regexes, captures data, whatever, Python, Perl, whatever your choice is there. You end up writing this code, reading standard input, throwing it standard out, or maybe you even write the socket listener. And I've rewritten this code so many times that at some point I just said, why am I continually rewriting this same code, or like copy and pasting this little code? It never evolves, it never gives me more advanced capabilities, and it's always this kind of complex, brittle machinery that to get my, to get traffic to my scripts. So, that was another thing just kicking around in the back of my head of how can we make this better?
So just to sum all of that up, why is this annoying? Because we often end up making a Rube Goldberg style machine, or this big kludge of a behemoth, just to start our assessment, just to get at that stream of data, and just to start manipulating things. And the problem with that is there's many moving parts. It's always done a little bit differently per application. Any one misconfiguration in any one part can lead to this thing just not working, and it can really be a test on your sanity trying to figure it out sometimes, because hey, what's going on? Oh, the ARP spoofing didn't get all the packets, and we were like, there has to be a better system. There should be a better tool that can do this automatically, because hey, we can do this very mechanically, but why is it not being done for us very mechanically? So, you want to take this one?
Yeah. Okay, so one of the things that we will say is that if you're going up against the known protocols, especially HTTP, but there are other protocols that proxies exist for. So if you're going up against these, there are really great proxies like Burp or Peros, or even PFI, which is a kind of smaller one. I guess more people might not be familiar with, but it's kind of a generic TCP proxy that isn't really transparent and aware. And we'll talk about what we mean by that in a little bit. Some of the times that matters, some of the times it doesn't. But again, you have to actually get the traffic to it through the routing of the IP tables rules, things like that. So the proxying traffic through a known proxy means that you're doing less work, but again, some of the time doesn't do what you want, or it's only for this protocol, and you've got this really great tool, but if you're not going up against that protocol, you still have to break the software somehow and get at the stream of data. So it's pretty important to us to solve this generically some of the time.
So we're going to introduce Mallory now, talk a little about the architecture, and then get into some of the demos.
Great. So now I'm going to give you guys kind of a tour of the architecture. We have quite a few demos planned for the end, but hopefully this won't last too long or be too painful. So basically this is our diagram. It's really straightforward. You have an application you're testing, you have a Mallory gateway somewhere in the middle, and then you have access to the internet, or maybe a test network or something like that. Essentially, Mallory can be running on a lot of different places, and Raj will talk about, he's really passionate about connecting things to Mallory, so we'll let him talk about that. But the important thing is Mallory is running on its own machine, usually a virtual machine, possibly a netbook or whatever, and traffic has to go through it. So that's like one of the key assumptions of how we implemented this, because hardware is just dead cheap these days, so there's no excuse not to power up a virtual machine with a few hundred megabytes of RAM. So Mallory is a transparent aware proxy, and what we mean by that is kind of like Squid is transparent in some configurations, where you can forward all the traffic from a machine to one TCP or UDP port, reach into the kernel, figure out what the real destination was, and send it on to the real destination. And that allows us to proxy the traffic, because we can then take the client connection and make the real connection to the server and sit in the middle, standard man in the middle. One of the things that we like about Mallory is that you decode protocols. So if you're going up against a known protocol like HTTP, we've added support for HTTP into the protocol, so you can do a little bit more than just generic TCP mangling of the data in the application. And for the cases where a protocol doesn't work, you can always fall back to the TCP version of the protocol handling, where it can forward generically any kind of traffic that's TCP or UDP. And for TCP traffic, we have a GUI-based debugger, which essentially lets you pause traffic, modify it, and then send it on to its destination, regardless of the protocol or where it's coming from. So we like that a lot. We think it saves us time. And as we were developing it, we realized that if you're man-in-the-middling an entire Ethernet interface, you're going to get a lot of extraneous traffic. You might only be interested in the traffic going from the victim to the server, and you might only want it for one specific port or even a specific payload match. So we developed a pretty sophisticated rule system to make sure that you're only getting traffic that you're actually interested in the GUI, because it can get a little overwhelming if you have 4,000 rows of stuff and you really only needed 10 of those rows. So we tried to make it user-friendly, because we've dog-fooded this pretty heavily internally. So we're trying to make it really nice for us first, and everyone else should hopefully like it. This developed through a kind of chain of different tools and ideas, and a lot of people have helped us out along the way. So these are some of the people that helped us. Mike Zussman started the original EV proxy that kind of gave us some of the initial ideas for this, because we started out with just an SSL man-in-the-middle proxy, and it just kind of grew out of control from there. Aaron Rhodes helped us with a lot of testing and a lot of ideas. He's kind of an idea factory. Raj obviously helped code this thing a lot. It was originally named Shaboopy, but the marketing department said that was not a correct name, so we renamed it Mallory, because it was pretty funny. There wasn't an actual tool out there that had picked the name Mallory from the traditional crypto examples, Alice, Bob, and Eve is always watching, and we said, well, there now has to be a Mallory, so that's where the name came from. That was Aaron's idea. Adam Pridgeon helped out. He's committed some code and helped out with, and pretty much the whole Intrepidus crew has committed ideas to us and said, oh, it should do this, oh, it should do that. And we've tried to make it better and better. And it's still a work in progress, but it's very useful now. So some of the things that Mallory does. When we say a protocol in Mallory, that means that we've implemented code to decode and interpret that protocol as a set of objects that a programmer can manipulate. It's a very hands-on process implementing a protocol. Not as hands-on using an already implemented protocol, but it's very neat. Mallory currently knows some pretty big common internet protocols: HTTP, HTTPS, SSL, DNS, and SSH. Those are the only ones we've implemented so far. So if we come across something that isn't using that, or it doesn't work with that, then we fall back to the TCP mode or other tools. But generally, it works pretty well. Plugins are specific to each protocol. So if you want to implement a plugin that lets you do something like, say, session hijacking of HTTP traffic, you can do that with a plugin, because plugin code is isolated even further from having to set up sockets and all that. You pretty much are given objects, you manipulate them, you return them back to the stream in the middle, and it makes it a lot easier, because there are so many layers of abstraction that you don't have to know a whole lot about Mallory to write a plugin. Just a little bit of Python and I guess some motivation. Plugins are extensible for all your man-in-the-middle needs when there's a protocol that's implemented well. So we tried to make Mallory a generic TCP and UDP debugger, but also a platform for developing man-in-the-middle tools that help you on assessments. And then we have a lot of options just to proxify traffic. So if you don't need to reach into the kernel, if you know the destination, you can say, okay, just throw all this traffic coming in from this Ethernet interface to this HTTP debugger, and then you can just use your standard tool chain to assess the application. So here's some of the places that Raj has routed traffic through Mallory.
Yeah, so the big thing about Mallory, it's pretty versatile, right? It's generic TCP, generic UDP debugger. The other cool thing is that you can put it in very many form factors. We have it currently running on all these form factors. So for example, we have it running at an access point at the office. Say we get a new mobile application, we just put it up on our phone, connect our phone to the access point, and now we have all the traffic going out of our phone into this access point into Mallory, where we can pause the traffic no matter what protocol it is, no matter what port it's going over, with no configuration other than connect to the Wi-Fi access point, pause this traffic, edit this traffic, fuzz it, and continue. Another fun one is the VPN concentrator, where say you have OpenVPN on some kind of device and you want to take any traffic going into this device and just throw it out to some Mallory appliance out on the internet, and now you have this just thing on the internet that you can have multiple Mallory appliances all over the world, just putting it there. You can pause it, record it, apply image flipping plugins, maybe data aggregation plugins if you want. You know, imagination is the limit there. We have it on the VMs that we're going to use for the demos, and you can put it on a netbook if you're like bored and you need a more powerful, let's say, Wi-Fi access point to do a lot more processing on more streams. But it's really cool. It's really versatile. That's what we like it a lot. For this specific, all the demos you're going to see just now, this is essentially the network topology. We have a VM that represents the Mallory gateway, which is the router. We have a Windows XP box, which is the client that will be running all of the applications and generating the traffic. If we had internet, it would be connected to that cloud, but we came prepared because we don't have internet. So we have a mock internet called example.com that's connected to Mallory, and all that is every box has a host file that points to that local IP. So we can show all the demos without internet access.
All right, we've actually released Mallory now, so if you go to bitbucket.org, you can download the source code using Mercurial. This slide deck is also available on our website, so that, because it's a little, the slide decks that are currently available are a little out of date, so our website has the most current slide deck and all the information for how to get the tool and where it lives and all that. So it's available now. You kind of have to set up your own virtual machine with Ubuntu 10.04 right now. That's our recommended platform, but we have setup instructions, and it's pretty easy. It's just installing a bunch of packages and running a few IP tables rules, and that's it. Mallory does require root, so the assumption is that you're going to run this on a completely isolated machine, because it does need to reach into the kernel to query kernel objects, things like that. It's already usable as a malicious access point, and you know, anyone could connect to your access point, but a lot of applications more or less force you to connect them to a wireless access point to assess them, so it has a lot of fun purposes as well. I won't really belabor the point of all these dependencies, but these are all just Ubuntu packages, so it makes life easy. There's no, you know, compile these 84 things, and if you're lucky and your C compiler was the right version, everything went in properly. You just got to install the packages, download a couple deb files, and have at it. This also highlights the strength of the Python ecosystem, because for the protocols that we implemented, we just had to tweak things. We didn't really have to, you know, sit down and say, all right, let's take out the HTTP RFC and implement this stuff. You know, we just yanked HTTP lib from the core Python code and had at it. So a quick comparison of some of the various proxies that we use from time to time, and we kind of we tried to pick categories we thought that are reasonable here. So transparent aware, I've kind of talked about our concept of transparent aware. Obviously, you know, guys like Ettercap that are doing their own art poisoning and stuff, they're obviously aware that they're transparently man-in-the-middling, but they're not doing it, you know, by querying a kernel and, you know, dealing with it at layer 3 or whatever. So, you know, in that sense, you know, Squid is, you know, very often considered a transparent proxy and it does almost the exact same thing Mallory does, but it only does it for HTTP. So that's what we mean by transparent aware. Extensibility was a really big thing, and a lot of these are extensible to, a lot of these proxies here are extensible to a greater or lesser extent. And our goal was to make extensibility one of the main features of Mallory, you know, for programmers ourselves, and, you know, hopefully as a platform for man-in-the-middle tools that people can reuse. Programmatic in-stream modification, meaning NetSed style features where you can run a regex on a TCP stream, and it can be a binary. You can specify hex bytes or whatever, and really get at the data. We have a neat demo for that. You know, monkeying with a VNC stream. Manual in-stream modification, where you can pause a TCP stream and modify the traffic and then send it on its way. We have a nice GUI for doing that. And then handling non-HTTP traffic, because HTTP is so ubiquitous. A lot of proxies only focus on that, and with good reason. But, you know, we still get stuck having to assess apps that don't do that. So Mallory is a standard UDP and TCP server. Talking a little bit about the architecture here. It just sits there and listens for incoming sockets. We don't we don't worry about layers below 3 and 4. That's not our concern. The only thing we have to do is talk to the kernel a little bit to figure out where to send the sockets. So by focusing on the higher level layers, we're not worried about a lot of lower level details that would just eat up our coding time trying to get it right. We focus on higher level concerns, and that let us do more useful man-in-the-middle type activities and application assessment, useful code. We have a concept of directions, client to server and server to client. Client to server is from a victim to a server, and then server to client is from a destination server back to the victim. We use that a lot inside of our code base and here and there. So if you hear us talking about that, that's what we mean when we say C2S or S2C. And then plugins are called right in the middle, invoked by a protocol like HTTP, and they just invoke certain methods, depending on what kind of plugin you're implementing. So a couple of quick notes on getting everything up and running now that you're a little more familiar with the architecture. Use Mercurial, and Bitbucket. Bitbucket is just a Mercurial, source code management hosting provider, and essentially you just run the hg clone command and clone our repository, and you have all our Python code and the setup instructions and all that. Then you can just read the README. It discusses a little bit of the network topology you have to set up. It can be as simple as 2 VMs, which is pretty simple these days. And then the setup file will tell you exactly how to configure the Mallory Gateway VM. Every package you have to install, and even goes into setting up Eclipse and PyQt a little bit for if you want to actually develop Mallory code and not just use the debugger. So walks you through setting up all the packages. So if there are any problems with that, we'll give you, you can contact us by hunting us down through our website or whatever. We're more than happy to help people set it up. We have command line options. They let you change some things. It is possible to run Mallory as a non-transparent aware proxy where it just takes data and forwards it on, but that was just kind of a feature request because we often have Mallory set up and traffic running through a gateway, and it's nice to just throw it off to some other destination some of the time. You can change the traffic database, proxify the traffic. These were just some of the options, kind of a leftover slide actually. We have a database, and data goes in the database, and it's really exciting. We capture all the TCP traffic and stuff it in a database, so it'll just capture all that, and it's kind of a pretty reasonable and logical database schema. We capture UDP datagrams, we put them in the database. If you're interpreting traffic on a specific port as HTTP or SSH, then that data probably won't end up in the traffic database in the exact form. The traffic database is just for TCP and UDP traffic that you're not really sure about what protocol it is. But it's still useful to maybe run the application and have that SQLite database for post-processing. So you can see, okay, where did this application go? What all did this device connect to? That kind of thing. It's just a little more friendly than Wireshark for manipulation from Python. We have interactive interfaces. We have a debugging GUI that we've talked a lot about. We're going to show it off just here in a minute. We have a GUI interface. Inside of the code base, there's a command line interface that doesn't actually really do much. It's just to show and illustrate how it's basically a prototype to see how you would talk to the XML RPC server that the debugger uses. So pretty straightforward if you're going to look at the code. Now we're going to show off the GUI a little bit and just kind of give a quick tour of it. It's not terribly complicated, so Raj is going to drive a little bit of our here. We have we have streams. So as data flows across it, and we're going to do some demos where all this data will populate, but we don't want to spoil the fun of the demo, I guess. But essentially what we have here are streams where you see the direction the traffic came in, the link, the source port and destination, the destination and the destination port, some just various data. It's pretty standard. Just fills in a big table. And then you can look at the text in two views, a text view or a little hex editor we cooked up so that you can insert bytes, copy them, and then paste them and do whatever you want to them to write them to a binary file or whatever. And then there are just a few extra buttons to intercept traffic, and when you do that, it tells the server to start sending traffic to the debugger. And then you can auto send the traffic if you're not interested in programmatic modification just yet. It'll just keep forwarding the traffic. And then the second you uncheck auto send, the traffic will not be forwarded. You have to forward it manually by clicking the send button with a particular stream highlighted. We'll make that all a little more clear. And then we have the rule system that I talked about, which is not too complicated, just a few different fields that lets you configure what traffic is going to get sent to the debugger. And this is also where you control something we call the muck pipe, affectionately named that, because it lets you muck with data as it flows through the proxy. It's basically a netsed style set of regular expressions that you can apply to traffic as it flows through the proxy. Some of the time you just want to do a really quick and dirty modification of data, and this facilitates that. Excuse me. So that's a quick tour of the interface. We're going to go over everything in a little more detail here shortly. Before we get to our demos, I wanted to just talk a little bit more about the extensibility, because we spent a lot of time designing the architecture to make it easy for us to implement new protocols and then implement plugins for those protocols. So that was really important to us because we were tired of throwing code away. So we wanted to have a nice home to live, and that nice home is completely dependent on how much time and effort you put into designing how you interact with the man-in-the-middle gateway. So we tried to make it neat and tidy. The documentation is pretty much not complete yet. What software project ever has complete documentation? But you know, we're going to work on that in the probably near future so that it's a little more clear how to implement plugins. But there are quite a few examples now, so it shouldn't be too hard if you're relatively well versed in software development or hacking up scripts and stuff. The plugin code is probably the smallest part of the code base. All right. So now we have a series of quite a few different demos.
All live demos.
Yeah. Well,
dun, dun, dun.
not on the internet, but we're hitting our example.com server because we knew that the internet would probably hate on us for some reason. So that's how it goes. Plus, who knows what kind of man-in-the-middle's on that blue cable there. So this was, we implemented SSH man-in-the-middle, and it was just kind of a thing I did on a lark. It's not something that I've actually had a lot of use for in assessment, but I wanted to use that to feel out how I'm going to implement the architecture, and it turned out that SSH man-in-the-middle with Mallory is really easy, and it's kind of cool. So we'll show a little bit about how we implemented SSH man-in-the-middle here. So this is just a standard, PuTTY SSH session that we're going to open up here. And we're going to go to our example.com server, open it up, and you get the standard warning because obviously the host key has changed. But that's a lot of text to say you're about to be hacked. So we're counting on people will not really pay attention to things like that.
And not only that, yes and no will hack you. Only cancel will be safe.
Ubuntu and Debian actually take the appropriate steps where if the host key changes, it just drops you. So if you're doing it from command line, you have to go edit the host file and delete the key. But anyway, enough of that. So we log in, and because we have plain text access to the terminal that's coming up, which is thinking mightily.
Yeah, hard drive. It's getting there.
It's getting there. Who knows what's happening? Our virtual machines are now thinking. Thinking, is Mallory running?
Yeah.
Okay. And essentially what it's going to do is, when it pulls up, it'll show a little example of, it injects a little bit of text in there, and then we can come to our Mallory server, telling it into it, and it'll show all the man-in-the-middle SSH sessions that we have currently. Who knows why it's not working? That's because
No, it's supposed to. We practiced this 3 times. All the host files are. Oh, there you go.
There it goes. Okay. So we injected that text. Things just got real. So we could put any text on the console and log any of their keystrokes. And on the Mallory gateway, now we can see their username and password that they typed. Just show a quick example of that. You can see our username and password that it captured. And the really cool thing is, right now, Mallory is maintaining an active SSH session with the intended destination, and it's authenticated. So now all we've got to do is telnet or netcat to our Mallory server, and we see that we have a couple of active man-in-the-middle SSH sessions. So we're just going to type in the number, which is just a little TCP listener. And what just happened is we have one transport, but the way SSH protocol works, you open up multiple channels. A channel if you're going to SCP files, if you're going to port forward, if you're going to get a virtual terminal, whatever. And we just opened up another channel, and it's completely invisible to the end user that was just man in the middle. He doesn't know that his authenticated transport was used for malicious purposes. So now you can modify a file or touch a file, and then we'll go over to our man-in-the-middle session, and it should be pretty clear that when we use the right command that the file that we just created is sitting there. This is the CLI test. That's just an example of a protocol. Basically, my goal was to look at how hard it was to do this, and it turned out not to be too difficult because there's a really nice SSH library called Paramiko in Python that's written in Python, pure Python. So that was pretty neat. That was a fun example of manipulating the architecture.
So.
Yeah, it's a few hundred lines of code, but most of it is demo and boilerplate type code. So that's SSH man in the middle Mallory style. Play the slideshow. Yeah. All right. Sorry about that. We talked about implementing HTTP. So we're just going to kind of show that we're actually interpreting HTTP requests intelligently on the wire. And we're just going to kind of grep our log and show, okay, here's the HTTP request as it flows in. We're going to pull up another demo for that. So we're going to just pull up a standard web browser and make some requests to our demo server. The images are flipped upside down. It's really kind of weird when you look at images.google.com and all the images are getting flipped and stuff. I actually did that so I'd know when I was man-in-the-middling myself because I couldn't tell without some visual indicator. So that's where the image flipping started. All right, so now we're just going to look at the log real quick. If it were TCP traffic, it would just say TCP protocol instead of http.forward or whatever. So you can see, get / WordPress or whatever. So that's just letting us know that the HTTP protocol is what's being decoded on port 80. Pretty simple and straightforward example. All right, so that's HTTP man in the middle. It's going to be next example is we're actually going to show off the GUI that we've created for doing TCP manipulation. So this is going to basically, we're going to turn off all the protocols and we're going to just interpret this traffic as TCP. We're going to say we don't know what protocol this is or we haven't implemented the protocol. And we're just going to launch the GUI. And then all the traffic from this victim machine is going to flow through the GUI until we tweak the rules to maybe just get at a specific protocol or something. So here's our Mallory gateway again. We're just going to run our command to launch the GUI. All right, so here's the GUI. It's up. It's not intercepting the traffic yet, but now we're going to turn it on, and all the traffic will start flowing through the GUI.
We can do the echo example.
What's that?
The echo example.
Oh yeah, we implemented an echo server just so you can kind of see a quick editing example of, this is how you would edit traffic as it's flowing through the gateway, and you can use this for binary protocols or whatever. But we wanted something that was simple and intuitive in our demonstration.
Yeah.
All right, so
I just sent this to the.
all right, so that's the echo server running, and now we can see actual traffic running through the gateway. So it's just showing you the text in that text box, saying this is a test. Pretty simple. So now we've turned on interception, and we're going to see what happens when we're trying to intercept all of that traffic. So now he's just typing in the string and press enter, and it didn't close the connection because the Mallory gateway is holding onto it. And we see that we have some unsent data. So it captures the first character just as a quirk of the way Telnet works, since it's going to line buffer the rest of it. So we'll send that traffic after modifying it. And now it'll send us the rest of the text that we type buffered. It gives you opportunity to modify it and then send it on along. So we save it. You always got to remember to click the save button. I've forgotten that many times. So we send that along, and now we can look and see what text the server, the intended destination got, and we can also see what the client got.
Oh, I didn't send it. Sorry.
Yeah, it helps if we actually remember to click our send button. But that's a good example. You have about as long as a TCP timeout to manipulate and modify the traffic in the GUI. So some applications might only give you 15 seconds. Some might give you a lot. That's why we have the ability to copy hex bytes and paste them over everything real quickly. All right, so that's essentially the main function of the GUI is editing TCP traffic as it flows through. But it's invaluable when it seems so simple, but it's really invaluable when you're trying to get the traffic and you've been going through layers of SOCKS proxies and attaching to processes and okay, where's the send function? Reverse engineering using Ollie or Immunity Debug or whatever. It can be pretty tiring. And that's only if your application, is something in an environment where you can even do that. So this is the muck pipe. I wanted to pick a real-world example of a protocol that's non-trivial and binary, and then show regular expressions operating against it. So our muck pipe more or less replaces NetSed. NetSed is still useful in a lot of places. I still play with it, but our regular expressions are powerful enough now that I barely find myself needing it anymore. So what we're going to do is tweak our rule set to just run the muck pipe on the VNC session. We have it run on port 5901, and this regular expression it's a little there are a lot of backslashes and forward slashes in there, but essentially what it's doing is a series of hex characters, and the regular expression format is then a forward slash and then what you want to replace it with. So what we're going to try and do is replace the letter A as it's sent through the VNC keyboard with the letter B. We're going to use the on-screen keyboard on the victim to show you that we're actually clicking the letter A, and this regular expression is looking for VNC keyboard commands and replacing them. So we'll pull up the on-screen keyboard and the VNC session and walk through that.
Wait, let me make sure it's auto send. There.
And if you don't turn on auto send, then it'll just sit there waiting forever, like that. All right, so this is the muck pipe, affectionately named by Aaron, sitting right there.
So we're going to be sending the uppercase A character.
So and that's a really simple example, but I guess if you really were passionate about Dvorak, you could remap everyone's keyboards to Dvorak. Whatever, it's just you can get really crazy with regular expressions. You can actually chain 10 muck pipe rules. I've done some pretty crazy stuff, and each muck pipe rule can have multiple regular expressions that are applied serially. So you can get pretty intricate just with regular expressions, as long as you don't get too carried away. At some point, I've done things where I'm like, okay, I just wrote 20 regular expressions. Maybe I should have implemented that as a plugin, but you can get carried away. All right, moving on to our next demo.
And that was done in stream, which is the coolest part.
Yeah, it's all happening in stream. As soon as you change the rule, it's instantly applied, and all the traffic will then have that rule applied. The next plugin we have is image inversion, which you've already seen. But instead of showing you the plugin again, we're just going to show off a little bit of the source code and show that it's only 20 lines of code, and you could essentially do that with anything on an HTTP session. If you want to, make the world black and white, replace CSS, whatever, any HTTP request or response that flows through, you can do whatever you want. So this is the code. It's how many lines is that?
6.
20, six lines to flip the image using the Python image library. Another 10 or 15 to actually implement the plugin, and that's it. You don't have to worry about socket code or anything. You have an HTTP request object, do stuff to it, give it back to the gateway, and away it goes.
So I just thought about this too. This is an example of the specific parts of those scripts that we would do all the time. without the generic parts that would have to be interleaved within there to get just the network information. All this is worried about is the logic of the assessment that we want to do, the logic of the data manipulation that you wanted, the data manipulation that you want to do. All the networking was taken care for you. If you just look at these few plugins that we have, you can get up and running pretty quickly. All right, next. Whoops.
So another thing that we did was, we have a session hijacking plugin, and this is really cool because any host and header cookies that we capture, we can use those and then man in the middle of them, replay those and hijack the session on the Mallory gateway. And session hijacking is one of those things that's been known about for years in HTTP. It's not terribly exciting, but when you actually have to do it and you have to click through 10 steps every time you want to do it in burp or Peros and replace cookies, it can be very tedious. So a way to automate that process for mobile devices that we're capturing headers and cookies for, and then use just a regular browser to test the application can be pretty useful. So we're going to pull up a browser and log into the WordPress admin side of the site and let Mallory collect a few cookies. So he's going to log in as an admin, and notice that it's still flipping all kinds of images. Did we get logged in there?
Not yet.
Oh. So all right. So as soon as we get authenticated to the WordPress site, you'll see a standard blog management screen. It's a little slow because it's running so many VMs.
Mm-hmm. So this is logged in right now in the client VM that's running through Mallory, and now we're in Mallory. And note, in Mallory right now, the gateway itself, we are not logged in. However, if we
all right, and before we go on here, I'd like to explain a little bit about what happened. There's an HTTP plugin in Mallory that knows how to do session hijacking. It's logging all these cookies because every HTTP request it sees and saves that data in memory. And then we have a separate daemon that when you connect to it, it gives you a bunch of JSON data that represents all that data seen on the screen. So this plugin is essentially doing an XML HTTP request and pulling a bunch of JSON back from the Mallory gateway. And now this is a Chrome extension that we wrote. And this Chrome extension will replace all the cookies. And the reason we use an extension is because you can violate same origin policy in an extension and replace cookies for any domain, which is what we want to do. So we click apply, and voila, man in the middle. Now every request you make to example.com, the extension is smart and replaces the cookies for you. So it makes session hijacking really easy in, I guess, 2 or 3 clicks.
Yeah, no more stopping the set cookie, editing it, sending it off.
And if you are using a proxy, it'll do this, and you can actually just send it to a regular HTTP proxy now with the hijacking already done. So that's kind of nice. And one of the final things that was just like another random thing was, okay, what if we do have an app that's using DNS and we don't want to have to do anything crazy to send it to an internal server? Like, say we have a binary protocol and we have an internal server that we want to, kind of maybe do some fuzzing. The client, we want the client to go to that server. We can hijack DNS. So DNS support is just for A records right now, but using the DNS Python library, if you so wanted, you could implement any protocol that you wanted. I'm sorry, any DNS record type. You can manipulate those. But so right now, if you go to CNN.com in the application, what?
Internet.
What? Oh, yeah. You have to take our word for this one. You can see, actually, if you look at the bottom, it's looking up for /.org, even though we typed in CNN. We didn't. This is the only live demo that won't work. But essentially, we can take a quick look at the code for the DNS configuration. But basically, any A record request, you can do simple string matching and replace it with whatever IP you want to throw it off to whatever server you want to throw off to. So that's just a nice little feature. I figured I'm already the man in the middle. I might as well do stuff like that. So that's a pretty quick example of how to do that. So it's just a Python dictionary. If you're not really fluent with the code, Python, it's just a data type where whatever's on the left-hand side gets searched for and it gets replaced with the right-hand side when it sees an A record request flow over. And that is basically all the demos we have planned and prepared for. I guess we'll just do a quick conclusion of everything we talked about. Mallory is our generic TCP and UDP man-in-the-middle proxy. We like it a lot. We use it a lot. It's extensile. It's versatile. It's open source. With the GUI is actually GPL'd because it uses PyQt, which is GPL'd. So any work done on the GUI would have to be GPL'd. But the rest of the code base is using the Python Foundation license, which is real liberal BSD-like. So there aren't too many restrictions on how this gets reused. We have a Twitter account that you can follow us. We'll probably, as we add more protocols and make it do more and dance and sing and juggle flaming chainsaws, I don't know. We'll announce that stuff there. And you can keep up on the project with the Bitbucket repository. They let you subscribe, RSS feed of updates and all that newfangled Web 2.0 nonsense. So that's it. That's our proxy, and we hope you enjoyed our presentation.
Do we have time for questions?
Yeah, so now questions. We have time.
The session hijack, the Chrome plugin, that was the same system as Mallory?
Yes. So the way a lot of the plugins work, especially if the plugin is running some kind of server or some kind of thing that you need to connect into it, is we follow this paradigm. Only local hosts can connect to Mallory because we didn't implement authentication, or we didn't want to have all this sensitive data out if it's on a network, something like that. So it checks to see if a local host is connecting to it, and the Chrome extension will only work that way. Or if you do SSH port forwarding, you can make it work through, I guess, other mechanisms. I've got it working on my VPN setups and stuff like that. And the same thing with the SSH man-in-the-middling. If you try to netcat to that port outside of the local host, it won't work.
We figure with the prevalence of SSH, you can just port forward and deal with it that way.
Yeah.
Any other questions?
Cool.
Yes.
Yeah.
So that was one of those things where actually breaking the regular expression apart. In theory, you can do everything that a Python regular expression can do, but right now it's limited to most of the stuff you can do in a Python search style regular expression and then the replace. Pretty much what you saw is what you get. You can specify the number of counts, the number of times you'll replace, or or you can set the G flag for replace as many times, but it's, what's that? No callbacks. No, not yet. That's one of those things where it's well, I know I'm going to want that someday, but I haven't implemented it yet. So
But plugins are relatively easy enough to implement as well. So if you can figure that out in some Python way, and we give you this object of data, you can start messing with it.
And that might be an ideal place to just write a regular expression plugin where you can do a full-featured regular expression. But because that's in the GUI, it's easy for us to mess with things pretty quickly.
Yeah.
So kind of changing off the callbacks thing, did you guys look at the Twisted Network framework at all?
So we considered doing it asynchronously, but a lot of the libraries that we wanted to use, I know that Twisted has its own SSH library, but it seemed like the prevailing paradigm for most of the TCP code out there for Python was standard threaded sockets, and Twisted is asynchronous and has its own way of doing everything. So we really kicked it around, and there were a couple of times where I said, threads are absolutely evil, and I hate threads, and I wish I'd used asynchronous. But I killed those bugs, so now I'm happy.
And also a big thing about making a new protocol is if Python already supports some kind of client library and some kind of server library for a specific protocol, you can just use that kind of stuff. So since a lot of the libraries do use threads as opposed to Twisted or asynchronous, it was just easier to do it that way. So are you guys going to make plugins for Mallory? It's fun. Any other questions?
Have you plugged this into network fuzzing at all?
That's something that I've really been thinking about, and I think that's going to be one of my goals for version 2 of Mallory, because it's an ideal place to do a lot of fuzzing. We just need to figure out, because a lot of protocols, when you look at the different branches of network protocol will take, like FTP or HTTP. It ends up, with a kind of graph or tree structure. So we've got to figure out how we want to replay that and get enough, traffic volume to adequately, cover and fuzz a target daemon or whatever. But it's definitely something I thought, wow, I could do some fuzzing here. So that's something that keeps kicking around in the back of my head.
Yeah.
Cool. Any other questions? So go download the tool and tell us what you think. We're really happy to be here, and hopefully you guys will get some use out of it.
Cool. Thanks a lot.